So 1 is definition, 2 is theorems, 3 is postulates, 4, 5, 6, in no particular order, is point, line, plane, and any of the slots. They could go anywhere. So again, 1 was definition, 2 is theorems, 3 is postulates, 4, 5, 6, point, line, plane. Okay, so some notes to add on here for definitions. Make my way through my board here. So definitions is one of the key words of the day. For definitions, make a note for yourself, and I'll tell you exactly how I'll phrase the question tomorrow. But a definition should always have a category for what category the word belongs in, and then have some sort of list of specific properties. So if we wanted to do a definition for a school is a place, could work, different category. What'd you say? Building could work, different categories can work. There's not one like, this is the only way you can make a definition for a school. It's a building, it's a place, that. What's specific about a school compared to some other building or place?
You learn stuff.
You learn things. If I want to do a definition of a hospital, it's a building again, same category, that
Helps people.
we could probably go
Takes
more
care of
specific
people.
than that. Yeah, how then?
Giving them medicine.
Yeah, medicine, doctors, nurses, health, something like that. The church definition is a building, the hospital definition is a building, but the school definition is going to be more education properties, and the hospital is going to be health stuff. The church, it's a building again, but we're going to talk more about the spiritual part of that, right? But anything you try to do a definition of, you need to put it in a category of some sort, and then you're going to need to have something special about it. Theorems, stand up. Theorems are things that you have to prove. Is the word theorem, does that remind anybody of another word you know?
Theory.
Theory, theorem. You sort of know, you sort of don't, you're not positive, you might need some convincing. A theorem, theory, it's the same kind of a word. Theorems are things that you're going to have to prove. So that was in there in number 2. Postulates are things we don't have to prove. For example, there's a thing called the line postulate. So in the world of postulates, if I said to you, or someone said to me, why is that postulate true? I would say to you, it just is. And you would just take my word for it. For example, there's a thing called the line postulate. The line postulate says for every 2 points, there's exactly one line that can be drawn that goes through both. If I commit to these 2 points on the board and I try to connect them with a straight line, that is the only choice I have. I do not have another choice. Why is that? It just is. I can't explain that to you why. No one can. It's just something that you see it and think, well, that's so obvious, I don't need a person to explain that to me. Okay, a postulate is something, it just is, you'll take somebody's word for it. A theorem is something that you have to prove. And if somebody said to you, why is that theorem true? You'd get some blah blah geometry stuff. You'd get some sort of big explanation about why that thing is true. So I'll give you an example of some blah blah geometry stuff. This would be an example of a theorem. You know from 7th grade, maybe, if it's still in your brain, that if you have 3 angles in a triangle, there's something that's true about them, mathematically speaking. Does anybody remember the math fact that's true about 3 angles in a triangle? They add up to 1/8. That is a theorem. I can prove that to you with a bunch of blah blah geometry stuff. you will not understand the geometry stuff I'm about to say because it's day one of geometry. It's going to sound like blah, blah, blah. You ever watch the Charlie Brown cartoons? You know, wah, 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 wah. Like that teacher talks and you don't understand what they're talking about. What I'm about to do will make no sense to you because it's just words and things you don't know. If I do this again in the middle of chapter 9, you'll know more words and things and it would make sense. Okay, but here's why that's true. If we have a triangle, this side is like a longer, like a mini version of this line. Okay, so that line includes this little tidbit of this. If I go up to the top, I could draw another line like this, and there's a word that you know. What's the name for two lines like that are never going to touch each other?
Symmetry.
No.
Parallel.
Parallel. Those are parallel lines. So we have parallel lines. I could draw parallel lines into this picture. Someday you'll learn the word transversal. A transversal is a thing like that that can cut through and touch both of those lines. And you don't have to write any of this down. If we draw in that transversal, this angle and this angle are called alternate interior angles. You don't know that word. Blah, blah geometry stuff is what you're hearing right now. But these have to be the same. If I draw in another transversal over there, these are more alternate interior angles. Those have to be the same. And then I've got this third angle here that it's just sort of there. It doesn't have a friend. Okay, but I've got an X, a single mark, and a double mark that fill the triangle. Along this line, I've got an X, a single mark, and a double mark. At some point we'll learn in the year that these angles have to add to 180. There's words like linear pair and supplementary and other words that we'll learn. But these have to add to 180. These have to each have a matching partner part of the triangle. So if those add to 180, those add to 180, that's why that's true. What did that sound like right now? Blah, blah, geometry stuff. Okay, that's what that was about. Geometry is going to build over the course of the year. We have to start somewhere. So anybody have a thought on, does it feel like we should start with more postulates or does it feel like we should start with more theorems?
Postulate?
Definitely the postulates. Why are the postulates a better place to start from?
Because we know how to do that.
Yeah, and if we say why, we're just willing to say
Just do
it just is. If we get into these postulates or into the theorems, you're going to have to understand the blah geometry stuff and speak that language, and that's not where we are yet. So we're absolutely, in the beginning of the year, going to start with postulates. It's going to be a bunch of postulates at the beginning, and then gradually we'll shift to theorems. But theorems are things that you have to prove. Okay? Proof is just, it's a logical, convincing argument is what a proof is. But we're not going to be able to do any proofs until we can speak the language of geometry. It's going to take us till about chapter 5 to really do that. So theorems, not so much early in the year. Theorems later are going to start to come a little bit more dramatically. But until we understand a little bit about how to do proofs, that's not going to come. Another thing that's where we're starting from is the undefined terms. The undefined terms are our other starting point. Because you can only do definitions in terms of other definitions, right? So if I say a school is a building that teachers and students go to have education, well then you could fire back at me and say, well, what's a building? What's a teacher? What's a student? What's education? I'm like, okay, well, education is a system where learning happens. Well, what's learning? Well, learning is an activity where things go in your brain that weren't there before. What's my brain? Well, your brain is a part of your body that learns things. I mean, you can keep going and going with those definitions, but at some point there has to be a spot where you just go, you know what that is, quit asking me. Right? Like, you can't do definitions forever. Okay? The point line plane, those are called undefined terms because we just sort of get what they are. Points, if I were going to draw on my board a point, what would that look like? a dot. Would this be a better representation of a point, or would that?
The left.
The one on the right.
Why the one on the right? Why is that a better representation of a point than that one, at least of the idea? This one's easier to see.
Because a point doesn't take up space.
That's correct. Okay, so on your quiz or somewhere in your notes where you're taking this, why don't you jot down the fact, points are supposed to have no area. Okay, what we're trying to do when we're talking about a point, we're trying to imagine that this is so very, 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 very tiny that it doesn't even take up any space. But for us to see it and talk about it, we've got to put at least some kind of a dot. Okay? And if all I do is put a dot like this little speck right here, I doubt if Lauren Wang in the back can even see this little speck. So it's kind of nice for her in the back if I'm drawing my points to be like visible. But the idea of a point is it's actually so tiny it doesn't actually take up any space. It's just, it's minuscule. Lines, how would I draw? I already drew a couple lines on the board by accident. What would I do to draw? What's a line look like?
That's just straight with 2 arrows.
Straight, we do the arrows at both ends. What do the arrows at both ends mean?
Goes on forever.
Goes on forever, both directions. Somewhere in your notes, jot down for lines. What we're trying to use our imagination for is that those actually have no width. If you can imagine, this is like so skinny, it doesn't take anything out of my board. That's what we're trying to use our imagination for. For us to see it, for me to draw it, it has to have some width so you can see it. But we're trying to imagine, and if we were trying to do it, that doesn't have any width. How about a plane? What's a plane?
A flat area.
A flat area. My board is basically a plane. If I want to draw a plane, I would draw this shape. Do you know what that shape is from Old Days Gone By? It's not a rhombus, it's a parallelogram. How's a rhombus a little different than a parallelogram? We'll get to that. That's not crucial for today.
Rhombus is more like a square.
Yeah, because all of the sides, all the sides on a rhombus are the same. But if we want to draw a parallelogram, or we draw a plane, we would draw a parallelogram. It's like a flat thing, like my board, or a piece of paper would be a decent concept of a plane. Just jot a note on there. Planes we're trying to imagine is like so skinny it has no thickness. So if you can imagine this paper were so skinny it didn't have any thickness to it, but it were somehow still there. Like that's the idea of what a plane is trying to represent. I think in the book they drew a picture where they had all these arrows coming out of it to mean that it goes on forever. I'm not ever going to do that other than this moment. That's just not necessary. But a blackboard, a piece of paper, a folder, you know, those are examples of planes. Taking a stroll back to the left. An idea of this whole like geometry system we're trying to build. Logic's great. We're going to use logic and thinking this year. Logic can help you check guesses. Logic can help verify observations. But sometimes, and in some of the homework problems, you're going to first have to just make a guess and see if it's true. Or have an observation about something. That's going to happen more so tomorrow's homework than tonight's. But sometimes you just have to start a process by guessing. Okay? At some point in history, people were trying to figure out how how far it was around a circle. Does anybody remember the word for if we're trying to go around a circle, what that's called? It's called the circumference. Somebody just had an observation somewhere in history that if you would measure through the circle, what's this part of a circle called? That's close. Radius goes halfway. Diameter goes the whole way through. Somebody just sort of observed, if you measure the diameter and multiply by like 3-ish, that was pretty close to the circumference, but not quite right. And then they just sort of made some more guesses. Well, maybe like 3.1, I don't know. What if we multiply by 3.1, is that right? That's closer. And sooner or later they figured out what is the number you multiply by to do that math? Pi, which is not how much? Anybody know the first few?
3.1415.
3.1415. It's more stuff. Okay, and that literally goes on without and or repeat pattern. It's just a crazy number. Okay, but that whole thing where pi got like, I I don't know, discovered, if that's the right word. Somebody had an observation that that was like a little more than 3, and then they worked on figuring it out. They took a guess, they checked it, and it went places. But that took somebody initially going, I don't know, maybe 3? Oh, not quite, go more. Let's write a definition. Can anybody write a definition for a rectangle?
4 lines.
Let's give it a category.
Shape.
Shape.
Four line lanes,
So 4 sides.
and 2 are different sides, like 2 share the same size as 2 other sides.
2 sets with parallel lines.
Okay, 2 sets parallel. So is this though? Is this a rectangle? No. So if we want to, we need another like thing to make that happen. 4 right angles. That'll do. How could we make this shorter? Anybody a suggestion on how that could be shorter? Change the category. So a shape that has 4 sides, that has a name of its own,
Quadrilateral.
quadrilateral. So if we started off calling it a quadrilateral, we would have only had to say these 2 things. If we wanted to make this shorter again, what would we have to do? Answer, pick a new category. A quadrilateral with 2 sets of parallel sides. That has a name. A quadrilateral with 2 sets of parallel sides is a parallelogram. So we could call that a parallelogram and say that it has 4 right angles. If we had to choose between definition A, definition B, and definition C, who's right? All of them. You might just have a different taste, style, or preference, depending on the way you wanted to do it. But there is no such thing as this is the only right definition. There can be a lot of right definitions for a thing. You just have to make sure, give it a category, and the more specific you get in the category, the less you're going to have to bother with a property list that goes this long. Like if you try to give this the category of it's a thing, that's not a very good category. Like now you've got a lot of more stuff to do with that. Question about what I'm talking about. Okay, so let me re-emphasize. Key point of the day. Eventually we're going to do proofs. That's a convincing logical argument. That's a ways down the road. You need to learn some words first. Where we're going to start is largely with postulates and undefined terms. We want to start with the undefined terms because they don't need definitions. We want to start with the postulates because we don't have to prove. The postulates you do not have to prove. A postulate, somebody asks you, it just is. It's just a fact. Theorems we'll get more into later. Theorems are things you do have to prove. If you can't prove it, it's not acceptable. If somebody asks you why a theorem is true, you need to be able to blah blah geometry stuff. And the blah blah geometry stuff, that's called a proof. The logical convincing argument of blah 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 geometry. That's what theorems are about. Question about the scheme. Let me look at next quiz. I'll flat out tell you almost all the questions on the next quiz so you know exactly what you're studying for. We'll do a dress rehearsal. So tonight reading, you want to read 1.2. When you read 1.2, there's going to be 3 points. They won't be quite as obvious as yesterday's, I don't think. One of them will be obvious if you just think and have general life knowledge. Even a person who had read not one word at 1.2, you could score 1 point tomorrow just by thinking. So if you're in there tomorrow and you're blanking, there's one question that's just a giveaway to people with general knowledge about like society is on there. But it's always a good idea to know, again, like read the section headings, read the topic sentences. What this section is going to be about is a little bit like historical and a little bit like contrast between this and that. So try to just pick up a little bit on just like, there's a contrast, there's a this, there's a that, there's some history, there's some stuff going on. But 1, 2, there's 3 points, give that a read. The quiz total is 17 though, so by far more important than reading for the 3 points, which you want to read for the 3 points, is study the 14 that I'll flat out tell you. So here's a question. There's 3 undefined terms of geometry. A blank, just yell it, point. Points have no area. There also is a line. Lines have no width. There also is a plane that has no thickness. So that 3 points just grew into 6. Points have no area, lines have no width, planes have no thickness, 6 instead of 3. A statement you have to prove is called a blank theorem. I will make you spell that correctly tomorrow to get that point. I didn't care about that today, but that is a word we're going to use this year about 100 times or more. I will demand you know how to spell that word. So T-H-E-O-R-E-M. T-H-E-O-R-E-M. It's just like theory, just put the E-M at the end of that. Then I'll follow up. For a theorem, if someone asks you why, how would you respond?
It just is.
Nope.
Geometry stuff.
A little more?
Blah, blah, blah. Geometry.
Blah, 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 geometry stuff. You get to actually write blah, blah, blah on a quiz. Seems strange, but it's true. Yeah, for a theorem, why is it? Blah, blah, geometry stuff. So 2 points off a theorem. A statement that we accept without having any proof is called a postulate. I will demand that you spell that correctly also. If you spell it funny, I'll do half point on you. P-O-S-T-U-L-A-T-E, postulate. For a postulate, if somebody asks you why, how would you respond? It just is. So 2 points off a postulate. A good blank should be clear and exact. Definition, I think that's the same way it was today, right? Is that how that was asked today? Yeah, so same way on that. And then I'll follow up with every definition should have a blank and blank.
Category.
Category,
Specific.
specific, properties. So every definition should have a category and specific properties. Which types of statements are our starting points? Postulates is half of that answer. Undefined terms is the other half of that answer. So those last 2 questions in a row, they were like in halves. So every definition should have a category, and it should have specific properties, 2 ideas for 1 point of answer. And then the starting points, we want to say postulates and say undefined terms, 2 sort of half points to a full answer. And then the last question for tomorrow, what is a proof? Logical convincing argument. Every question I just said to you, there were 14 points worth of them there, makes it tomorrow. Every one of those 14 points will be back on Tuesday after we have off Monday for Labor Day. Every one of those points will still, I think, be there on the Wednesday after Labor Day. Maybe I start trimming them a little bit on Wednesday, but when we get up to, here's 2-3, it's still asking you for proofs and theorems and postulates. 2-4. 2-5 is where finally things like stop being on there. So there's a lot of repetition to the things. Does anybody need a recap of what I'm saying, some of those questions were?
What was the second to last one?
Second to last one, what's our starting points? Postulates and undefined terms. Question on that? Let's look at homework. I'll preview some homework and give you a couple homework tips on here. For number 1, it's just sort of general knowledge dipping into your memory. Some of you will know some of these shapes. Some of you will know not that many of the shapes. If you don't know all the shapes, how in 2022, or in the future, if you're watching this video beyond this year, how could you get names of shapes if you forgot them? Google, yeah. Go to Google and punch in common geometry shapes and see if you can find pictures of them and match them up. So if you need to use Google, go for it. You go to do B and you remember what perimeter is. Do it. If you don't remember what perimeter is, Google it. You go to do C and you don't remember how to do C with perimeters and areas. If you remember it, do it. If you don't remember it, Google it. Likewise, D, E, they're talking about radius and circumference and things. If you don't know it, Google it. Google is fine. Look it up. 2 needs a little bit of explanation. People don't always understand 2 right away. So here's what they're talking about in number 2. They're drawing you a weird little chart. I'll draw you a different weird little chart. So they're saying, imagine you look up word A in the dictionary, and it tells you word A means the same thing as word B or word C. If you looked up word B in the dictionary, it might take you to word D or word E. If you looked up word E in the dictionary, it might link you back to word A. I just created what's called a circular list because I started with the word A, I found a word B, I found a word E, it linked me to a word A. Since I started with A and ended with A, I just found a circular list of words. That would be a circular list of 3. From A to B to E back to A. I only used 3 words. A linked to B, B linked to E, I got back where I started. That's a circular list of 3. Anybody not understand what I mean by that's a circular list of 3? So can somebody find me a circular list of 2?
The A and C.
Yeah, AC back to A. So if we go from A to C back to A, that's a circular list of 2. Can anybody find me a circular list of 4 other than Joseph, who just did the list of 2? Correct. If we follow this path, A, B, D, F, back to A, that's a circular list of 4 because we started and ended with A. That's what they're asking you to do with the chart. They just used actual words. Question about 2, what that's about. If you don't get number 3 right, I don't know where you've been all period or what you read last night. Number 3 is pretty much a giveaway point. 4, they're asking you to make a drawing. I drew you some points and lines and planes. They're asking you to try to draw some points and lines and planes similar to what we drew. So that's 4 is a drawing question. 5, they're doing some definitions. 5 is going to be looking at a definition and deciding what you think is bad about it. Then 6, they want you to try to write a better definition. Why should it not be a giant problem to write a good definition for any word in 2022? Look up. If you can write it yourself, write it yourself. If you just flat out can't write a definition, look it up. Use a dictionary, use Google, use your phone. Ask Siri. Siri, what's a rectangle? You know, bing. A rectangle is a parallelogram. You can access that anywhere. But the question on 5 and 6 are linked. 5, you're trying to come up with a criticism of what they're doing. 6, you're trying to come up with a good definition. It might be easier to use Siri to get the good definition than it is to apply to criticize theirs, but that's what you're working on 5 and 6. And that's the homework tonight, goes 1 to 6. Question on that? So one more time recap. 1 to 6 is homework, starts on page 4. Use Google if you need to, or Siri, or whoever, sister, brothers, whatever. You're reading 1, 2, 3 new points, and then 14 points of recycled material. If you wanted to start on page 9, you could. You don't need any information from me, really, to do page 9. So if you're in a work ahead mood, because you don't have much going on tonight, then go ahead and do that. But